Hi, my name is Nicole Thied. Today we're going to be talking about supernovas, specifically type 2. So what is a supernova? It's the explosion of a star due to a change in the core of that star. And supernovas are really interesting because statistically, one happens every single second somewhere in our universe. They're also really cool because there's two different ways they can occur. First is type 1, which happens in a binary star system, where a white dwarf will start to accumulate some of its companion star until the white dwarf explodes. Then there's type 2, which happens at the end of a single star's lifespan. We're going to be talking about type 2 supernovas. In order for them to occur, the star needs to be very massive. In fact, it needs to be at least 8 times more massive than our sun. Eventually, that star's core will start to run out of its nuclear fuel, like hydrogen and helium. When this happens, the mass of the star will start to flow into the core of the star. Here, it starts to form heavier elements like carbon. And similar to an onion, the star begins to have layers, with the heaviest elements in the middle layering out to the lighter elements. When this happens, the core becomes supermassive, and it reaches a limit where it starts to implode on itself. When this happens, the core gets super dense and super hot, to a point where these layers, as they implode, don't want to implode anymore, and they eventually bounce off of that dense, hot core, exploding, causing a supernova. So to demonstrate how these layers bounce off of each other, we're going to use just a simple tennis ball and a ping pong ball. When we drop the tennis ball, it only bounces about a foot off the ground. Drop the ping pong ball, same thing happens. But if we drop them together, that ping pong ball goes ricocheting off way farther than it could have ever by itself. This is similar to a star. The floor is like our core of the star, and the tennis ball and the ping pong ball are like the outer layers, heavier to lighter, of that star. As they hit that dense core, the ping pong ball ricochets off of the tennis ball, which bounces off, exploding out into space. After supernova occurs, what's left of that hot, dense core? If it's less than 2 or 3 solar masses, a neutron star is formed. If it's more than 2 or 3 solar masses, it falls into a black hole and becomes a black hole. Here we have a picture of the most famous type 2 supernova, SN 1987A. This is before and this is during the supernova. Really cool because it's an actual picture. We know a lot of things about supernovas. In fact, we know almost everything. The one thing we don't know is why those outer layers eventually don't go all the way into the core and bounce and ricochet off. In fact, scientists try to simulate this with a computer, and a lot of the time the computer can't. It just shows the layers still going into the core and not imploding. So they need to figure out why these layers decide not to implode into the core and eventually ricochet off. And that's type 2 supernovas.